going to show you two ways to do this question. First of all, the way I did it, which is kind of like a bit of trial and error guessing, see if it works. And then secondly, like a slightly more rigorous way. So I'd advise sticking around for that as well. Okay, the way that I did it was to think, right, I want to try and make the edge sums as large as possible. So first of all, I'm going to put the smallest numbers in the middle. Just let's see if that will work. Okay, so I'm going to kind of try and draw a little triangle here. These are not being used. Then I'm left with all the other ones. So actually I labeled it A, B, C, D, E, F, G, and so on, but I don't think I need to go into that level of complexity. I did it at the time. But now I'm going to instead just say I'm going to try and put the largest numbers on the edge. If that didn't work, then my method would be to try the next lowest one or whatever, um, and so on. But yeah, I'd be getting into difficulties there. So it is actually going to work this way. Right, so I'm then got my sum, if I call it S, along here, then 3 lots of S is going to be, I'm going to double count the 13s on top. I'm going to count them twice, sorry, because I'm going to count the 13 along here and along here. So it's going to be 2 lots of 13 plus 14 plus 15. And then I'm going to add the remaining numbers. I forget how many there are, 9. So it's going to be 4 plus 5, 6 plus 7, and so on. Okay, so these add to give 27, 37, 42, 84. And then there's numerous ways you can add up these numbers. Probably the quickest in this case is to kind of pair them up. So that gives 20, these give 20, so I'm on 40, 45, 52, 63, 72. Just be careful, don't make a mistake. 72. And the thing is, actually, this is really good because we we needed this to be divisible by 3 to get what S is, and it is. This is divisible by 3 because the digit sum is 12, and this is because it is 9. So let me just work out 3S actually. 3S is going to be 156. So then S is going to be 52. Okay, that will be our sum. Question really is, I mean, that is going to be the answer actually, but we haven't quite shown that you can actually get there. So that is the remaining thing. I think I've got to try and get 52. Well, it makes sense to try to use the smallest one here with the two largest, 4. And that's gonna, yeah, and then the second one would be 15 if it would be here, and then 6 here. So where are we up to? I've got 27, I've got 33 here, I've got 33 here, and I've got 33 here. So that is good. I've dealt with these. And now I can just pair them up into 19s actually. I can put 7 and 12 here, and then 8 and 11, say here, and then 9 and 10 here. So I've actually demonstrated one way of creating this triangle. So therefore I've used the 3 smallest ones in the middle, I've used the 3 largest ones on the corners so that they get used more than once. We've shown that when we add them all together, we in fact get a multiple of 3. We divide by 3, we get the sum, and then which is the answer. And then I've just demonstrated that it is possible to create such a construction. Nice. All right, second way of going through this question, worth a look. I did appreciate this when I watched it. So instead of saying I'm going to put 1, 2, and 3 in the middle, we're going to say that we're just going to put A, B, and C in the middle. And then on the corners, we'll put D, E, and F. We just don't know what ones there are. And then we got some here. Right, this time, 3 times the sum is going to be all the numbers from 1 to 15 But we're going to have to subtract A plus B plus C, because I feel like I just need to justify this a little bit more. Like I'm adding them all up, because I know that they're here, here, and here, but I'm then going to subtract the 3 in the middle, whatever they are. So if they're 1, 2, and 3, I would be subtracting 1, 2, and then 3. And then, because we double count the ones on the corner, I will then add D, E, and F. So that is a general way of writing down the summation. Okay, now let's work out what 1 plus 2 plus 3 all the way up to 15 is. In fact, I didn't talk about this before. There's a really quick way of doing this, and it's to do half times 15 times 16, which is 8 times 15, which is 120. The general formula, if you're adding n, the first n consecutive numbers is a half n plus 1. Really useful to know. It's a formula for triangle numbers. Not going to go into detail on where that came from here, but do look into it. So now we've got the s is therefore going to, we can divide through by 3, and it's going to be 40 minus a third a plus b plus c plus d plus e plus f. Sorry, a third of that as well. Okay, so that is our general formula. Really nice, because now we just see, right, I need to try and make this a multiple of 3. And I want to also make it as small as possible because I'm subtracting. So hey, why not try 1 plus 2 plus 3, which is 6? That will work. And then on the corners, right, I want to make D, E, and F as big as possible. So why not try 13 plus 14 plus 15, which is 42, which is a multiple of 3. So also happy here. Therefore, I'm going to get 40 minus a third of 6, which is 2, plus a third of 42, which is 14. And that'll be the same as 40 plus 12, which gives us 42. Okay, so I really rate this method. I think if I was doing it again, that is what I would do. My method got me there, but it was like, what would I do if it hadn't have worked? Whereas this method, because we have this general equation for for s, oh, here we are, then it's much easier to kind of mess with the numbers to make it work and get the largest amount. Nice.